Among the most profound discoveries in cosmology is this. Space was once filled with a nearly uniform glow, a whisper of light stretched thin and soft, rippling gently from the first moments after creation. This light still surrounds us today. We call it the cosmic microwave background, or CMB. It's the oldest light we will ever see, a frozen snapshot of the universe when it was just 380,000 years old. Before that moment, no light could escape, not because we lacked telescopes or technology, but because the universe itself was opaque. Atoms had not yet formed. Electrons and protons drifted free, scattering photons like fog scatters headlights. There was no transparency, no sight, only heat and chaos. Then, something changed. The universe cooled just enough for atoms to form. Suddenly, photons could travel freely. The cosmos became transparent, and that first light began its journey. Today, billions of years later, we detect that light with precision instruments. It's cold now, just a few degrees above absolute zero. But it still carries the fingerprint of the early universe. Tiny variations in temperature that reveal the seeds of galaxies, the structure of space, the geometry of everything. Those slight ripples, just millionths of a degree, tell us that the universe began with quantum fluctuations, amplified by a process called inflation. Space expanded faster than light, smoothing and stretching those ripples into the vast structures we see today. The CMB is a kind of cosmic fossil, a time capsule. It tells us what the universe looked like before stars, before galaxies, before the first atoms cooled into place. But it also marks a boundary, because no light from before the CMB can reach us. The universe before that was invisible, not just in practice, but in principle. There's a kind of wall there, a limit to what photons can tell us, a cosmic curtain drawn over the first instant of time. So how can we look beyond it? Not with light, but maybe with something else. Gravitational waves, ripples in space-time itself, may have been created in the first fractions of a second after the Big Bang. These waves are not blocked by plasma. They pass through everything, and if we can detect them, they could reveal what happened before the universe became transparent. This would be a different kind of observation, a new kind of seeing, not with light, but with gravity. And it's not science fiction. Instruments like LIGO and future space-based observatories are already hunting for these primordial waves. Their discovery could open an entirely new window into the pre-light universe, a glimpse into time's very beginning. But for now, the CMB is our oldest messenger, a silent echo from the dawn, a map of what space looked like before it grew stars or formed galaxies. It reminds us how far we've come, not just in distance, but in understanding. We started with myths, then with telescopes, then with equations, and now we read the faint afterglow of creation itself, recorded in microwaves, like starlight frozen in time. The universe doesn't speak loudly, but when it whispers, we learn everything. And the message from the CMB is this: we are part of something ancient, something vast, something that has been unfolding longer than any civilization, longer than any star, longer than light itself. And somehow, from a quiet planet orbiting an average star, we've heard that message. We've understood it, and we've begun to ask what comes next.